So I provided two versions of tests from before. I kind of translated them to Python because they were originally posted in MATLAB, but conceptually they're the same. So one that I'd like to, that is a little bit of a catch, is the one from, it is 1B from test from 2011. So I'm going to say problem 1B, spring 1. Okay. And that one says compute the value of matrix C. Does everybody have a copy? Compute the value of matrix C where alpha is given and it's 2. A is NP array. First off, the way we define two-dimensional arrays is using NumPy. So I've got to import NumPy as NP. An NP array, I open the brackets, and then I go with the first row, comma, second row, and so forth. So in this case, it's 2, minus 1, 1. Don't forget commas. Then comma, that's my first row. Then I open the brackets for the second row, 4, minus 2, 1. And third row is 1, minus 1, 2. So let's just print A to see that we did it correctly. Okay? This is my A. So know how to define an array. In this case, it's two-dimensional array. If I had one-dimensional array, then I don't need this many of the, so then I just have one of these, right? So how do I now subsample this array? If I just wanted to say, hey, print A of 0, 0, 0, that would be my element 0, 0 is basically the first of the existing rows. We start with 0. So 0th row and 0th column. Okay? And that is 2. That is this element right here. However, there is a way to use column notation to subsample multiple rows and multiple columns at the same time. Okay. So to grab multiple rows and multiple columns at the same time, I can use colon for this range, and that's where this kind of thing works only with arrays. So if I do 0, 1, that's a little too restricted. Let's say 0, 2. Okay? 0 to 2 written this way. Remember, in Python, it's always like a silent last number in the range. So this is really 0 and 1. Okay? So that's going to take rows 0 and 1 and column 0. And what it gives me back is just those, if it's a one-dimensional array, it doesn't care whether it's a column or a row. It just spits out those two numbers. Yes? Can you do multiple columns? Yes. And that's our next thing. So go ahead and do it. Don't be afraid. Okay? You're not going to break anything down. It's just going to say error maybe. But so this is rows 0 and 1 and columns 0 and 1. So 2 remains outside of the range. It's always strictly less than the same as a range function, right? You can do basically, if I do 3, then I'm going to do all of them, all of the columns that I have in this particular case, because I have 0, 1, and 2 column, right? Are we clear on how subsampling works? Okay. Great. So now when my B was something else, my B was NP array And this was a 2 by 2 matrix, so first row is 3, 2, and the second row is 1 minus 1. So I'm not focusing on this output looking pretty, but I could say B equals to B. A equals 2. So then this first part is a string. It's going to just print string and then the actual values. And frankly, this is my chance to get picky. I'll let it jump into the next line because then things are aligned under each other a little better. Everybody sees what I'm doing here? Reviewing print command in the same breath as doing this example. So the first part is a string, but slash n will get into the next line, and that's going to align these numbers under each other better. Says my picky self. You might not be so picky. All right, now I wanted to compute C. So if I were to do this on paper, I need to compute C, that is alpha times, so I'm just going to say print alpha times A of 0, 1 and 1, 2 and times NP transpose of B. Can you do this on paper? What is it? Because I'm actually asking in this problem, hey, read this code and then do it on paper so that I see that you understand what the code is doing. Don't execute, do it on paper. See that you understand. Don't execute. And if you're bored, change this to 2 and this to 3. I don't like being people bored, having anyone bored. So a variant of this would be 2 and 3. So what did you get in this first one? Alpha is 2. What is this object? What is the dimension of it? 1 by 1, so it's a scalar. Which one? Which scalar? -1. Okay. So this really is just -2 times transpose of B. And transpose of B is 3, 1, 2, -1. What? Alpha is 2. This is actually just one number. It has to be strictly less than 1, so it's just really A of 0, 1. The way colon works is this, you have to be strictly less than this number. It's a range, but it's a range between 1 and 1. It has to be less than 2. So this is just one number. Which one? A of 0, 1, and A of 0, 1 is -1, this one here. So that's -2 times transpose of B. Okay, so that's 6, -6 -2 and 4, -4, 2, something like that. Yes, minus 6, minus 2, minus 4, and 2. Now, what is different in this second line, if you had to do it on paper again? What is this object? This is now 2 by 2, right? Which one? I take rows 0 and 1 and columns 1 and 2. So it's this portion of it. Minus 1, 1, minus 2, 1. Everybody sees that? If I just write times transpose of B, the second matrix is also 2 by 2. B is 2 by 2, and this submatrix of A is 2 by 2. And if I just I just execute times, what operation is done on these two matrices? Element by element, I hope that's what I hear. So I'm going to take corresponding elements and multiply them. It's not matrix multiplication. For matrix multiplication, I'm going to do NP mat mul of AB. Okay? So when we do this, it's going to be this minus 1, 1, minus 2, 1 times transpose of B. So 3 times minus 1, minus 3, 1 times 1, 1, and so forth. Let's execute. It's minus 6, 2, minus 8, and minus 2. Be sure you understand that on paper. So the difference between just writing times, I have two matrices of the same sizes, and having just times, it goes element by element. Whereas if it was actually matrix multiplication, I would have to do np.mat_mult of these two different matrices. Oops, I did something. Okay, I have matrix 1. I thought 2 was enough. Okay. End of. Where do I put a? Oh, hi. That's a weird little typo. I'm still not happy with it. So let's just do this. I have a typo somewhere. Let's do without. Yes, so this is done correctly. So what is the problem then? Alpha times. Didn't like the print command. Well, this is what I thought I typed in, but apparently I had probably an extra comma or extra bracket somewhere that I didn't see. Questions?
Do they have to, in order to element multiplication, do they have to be the same dimension?
Yes. Whereas for matrix multiplication, I have to have the corresponding number of rows and columns.
And then when you're doing scalar,
Columns and rows.
when you do the scalar times the matrix multiplication, does it matter if you do the scalar to product or if you charge scalar first?
That doesn't matter because you're just multiplying it by scalar. So this is the peculiarity of the computer thing. Basically, it's going to recognize, oh, it's a scalar. I'm going to multiply every element with that. Okay. Which is what we do in math as well.
When it's like the element multiplication, you can only do it
size or shape or whatever. So if you want to program robustly, you would go with if and check that the size, shape is the same. Yes?
I just tried out doing a 2-box here, which is what I can do. I'm doing that element wise, and it still gives me a 2-by-2.
Yes,
It
because
doesn't like an asphalt technique.
technically it interprets them both as one-dimensional arrays. Like Python does that, it just conflates. Yeah.
But in that case, I should use math.
Yes. Yes. If you want a 2-by-2 algorithm,
Can you remind me again real quick? 0 to 1, comma 1, 2. Is that one?
it's a range. It's 0 and 1, but it has to be strictly less than 1, which is only 0.
So is that the
So
first
the
one?
value is to a of 0, comma 1.
So the first one is a column, the second one is a row.
No, first one is a row, second one is a column. It's always row, column. So range of, so this is a way to specify a range of rows and range of columns and intersect them, okay? And get a submatrix.
So the first one's a row.
But the first one, yeah, row, column. Okay? All right. So that's the one that I wanted to pick out to do. What's the next thing you'd like to get solved? Let's maybe focus on test 1 from 2011, since I did quite a bit from the other one last time, but up to you.
I don't know if it's on this other question. Could you just explain how to decide whether to do roundup error or truncation error?
So what is a roundup error and what is a truncation error?
Or like,
So truncation error happens when I have a mathematical formula, okay, and I take only that mathematical formula might have infinite number of things that I'm summing up, and I stop somewhere, and I take first 1, 2, 3, 4, however many I take. Whatever is left that I didn't take is truncated.
so are all series or
Yeah, all series, all Taylor series, Maclaurin series, and so forth, I gotta stop somewhere. So that's the most common one is Taylor formula. And Maclaurin is the same, it's just Taylor around 0. It's a special name for Taylor around 0. So that's that. So that's truncation error. Roundoff error actually happens when you have more digits in a number than you can store in a computer. Then you have to round it up. So in the decimal system, if things were decimal, there's no problem using that example. 3.126, if I had to round it up to fit only two digits after 0, then I would do 3.13, and that's a roundoff error. And essentially, whenever we're working with numbers, both of them show up. Okay.
And one of the questions was like if you're running a function or something from a file, would that be
I don't know anything about the function, so yeah. Function might be print hello, right? So first one is a row, second one is selection of rows, and then columns. Separated by comma. Comma is the... Okay? Alright. Any other, or shall I pick? Do you know how to plot a 3D surface? No? Let's then just continue with the 3D surface. That's problem 1D. Okay. So consider the following equation for Z. Can we get a little bit of silence, please? I'm loud. I'm not that loud. Okay. So I have Z that is 4 sine of 2x plus 3 cosine of 2y. So Z is Z of xy. So it's a function that depends on 2 variables, and I want to plot it. The first problem in every plotting is creating data. And we do have help from computational resources in how to do that, but essentially I gotta sample my x's, sample my y's, create a grid, okay? And on that grid I gotta compute my z's, and compute it for every x and y. And since I'm going to sample finite number of x's and finite number of y's, I always have to go finite. Okay? Let's say n by m, right? I'm going to have n by m pairs of numbers, okay? X's and y's, that I have to compute z for. And that's why basically matrices are the ideal way to represent this problem. So as long as I can actually create matrices of x's and y's that are corresponding x and y coordinates on this two-dimensional grid, I can easily compute z just by using my NumPy array vectorization that is built into all of them. Okay? So if I have two matrices, x and y, let's say that I just assume I have matrices x and y, my z is simply, right, it's 4 times sine of 2 times x plus cosine. And where are these functions located? NumPy. So I'm just going to say import NumPy as NP. What was that? So if I had matrices x and y, but I don't, and it's function mesh grid that will help me do them. So basically I'm going to sample x's, and my x's should be between 0 and p. So I'm going to just say, okay, give me x's that are just lin space 0 and p dot p. And how many points do you want? 10. How many points in y? Also 10 or 20? And it's 2 times. Also 10 or 20? Or more? Any opinions? 20, thank you. We need somebody opinionated. Now these are just linear arrays, right? And it's the function mesh grid that replicates x's as rows and y's as columns, and basically gives me the other way around, but it gives me matrices of corresponding this is basically me building these matrices of one has x's and the other one has y coordinates on a grid, and then I just compute z's based on the formula, because z is a z of x and y. And now I have x's, y's, and z's all in corresponding places in 3 matrices, and that's what I can use my 3D plot functions on. Okay? So I need to have data like that to plot it. Yes? So again, I'm going to explain here. So this is my x and y. So if I sample x, and it's from 0 to p, let's say that I have 4 points, okay? These are just 4 linear points, right? If I sample y, let's say that I have 3 points, it doesn't matter, these 3. They're just 3 linear points. what I need is these, which are combinations of all possible x's and all possible y's. So basically what's this going to do, x is going to be returned as these values of x here, whatever they are, they're going to be replicated in this row, and then in this row, and then in this row. Or rather, no, x's will be replicated here, 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 and here, and y's will be replicated in rows. So I'm going to get a matrix where my x matrix will have x coordinates of these points. And I couldn't have written this smaller. Sorry about this. I wrote it right small. And your y matrix will give you y coordinates. Yes. So one of them stores x coordinates and the other matrix stores y coordinates of these points. Okay? Yes? So it's just a function that returns those. I could technically ask you, hey, create, do a for loop and create these matrices. Because it's just, they're just replicated. Okay? So if you write it down on a piece of paper, you can actually write mesh grid yourself. Okay? But NumPy already has it. So once I have them, I can then plot. So this is creating the data. Now I actually need to plot. What do I need to import for plotting? That's always PyPlot. And the other one for 3D? This? So this is what I need for 3D plotting. So in itself, these plots are two-dimensional. Okay? So there is an issue of figuring out how do I plot something that is a three-dimensional object. Okay? There are projections involved and whatnot. Without going into a lot of details, right? I gotta know where am I standing, where is the object, and how am I projecting things that I'm seeing. So that's what all of these are functions that do that. Okay? So you just need to import them. First, we're gonna create the figure. And that's just regular figure. And that's why I need matplotlib. And then I'm gonna say, hey, I'm telling you, create a subplot in this figure. It's gonna be the only figure. That is 3D projection. Okay? So basically the function is add subplot. So and since I want to work with this function add subplot returns an object, and I'm going to call it axis, AX. And it's to that axis that I'm plotting my surface. Bare bones, what I need to do is just say X, Y, Z. Then sometimes I need to execute this twice. Kind of pretty. for testing purposes, this is basically it, okay? I know we can add labels and all that to 3D plots. Do know how to do labels for 2D plot because that's the plot you're mostly going to use. But I just want you to know this procedure for 3D plot. How to create the data, most importantly. And then which functions to invoke. Yes?
To control the like X and Y and Z ranges, do you just control that when you define X, Y, and Z, or do you do like X?
You can do AX dot and that's set axis, yeah.
That works in 3D too?
It works slightly differently. So basically there are examples that I provided, but you can just put AX dot and then set the limits and labels and all that. So it's label by label. This is telling it to fly. And I could have done contour. Kind of cute. It's a three-dimensional contour. I could have done plot wireframe. So any of these functions. Again, what I want for testing purposes, I want you to know how to create the data. Just do a basic plot. Dressing it up with labels, forget about that for 3D. There it is. Twice. Enter twice. For some reason, it wants it second time. Okay? Ah, 3D plots. What is the next problem? Or should I just pick it? Just pick? I'm going to go with problem 4.
Which one do you think is the best one?
Because it's doing a function and all that. So it's a tridiagonal matrix. Tridiagonal matrix is a square matrix with same number of rows and columns with non-zero elements on the main diagonal. And to the left and right of the main diagonal, but zeros everywhere else. And there's an example here of how such a matrix looks like. Create a function called tridiag that creates the tridiagonal matrix A, so that's what I'm returning. When sent a vector of the main diagonal elements D, a vector of the elements to the left, and vector of the elements to the right. Okay? And then I assemble this matrix. You may not use any built-in functions outside the random function, length, shape, length space, log space, and zeros. So let's do this step by step. This is where you do want to be, and then call that function, but using the elements below. This is where you want to do an example first, and there's this example that I've written, or we can just do this smaller example, either way. So you want to recognize the rule of how do you create this, so there's some logic involved here. You just have to look at the problem and figure out what is the rule, how do I create this? Typically with some, if I'm creating a finite matrix with like specified sizes, it must be that I'm doing the for loop. Okay? And since it's a matrix, possibly even double for loop. We'll see. So what is the rule? Let's first figure out the rule. So let's do an example here. 3, 2, 0, 0, 0, 1, 4, 7, 0, 0, 0, 1, 1, 4, 0, 0, 0, 3, 1, 3, and 0, 0, 0, 2, 5. my main diagonal. Yes? So for that main diagonal, this is my A. This 0, 0 element, so let's say that this is my vector D. Okay? This is D of 0, D of 1, D of 2, D of 3, D of 4. Yes? So first things first, if this is my diagonal, what is, and this array has n elements, in this case 5, what is the size of A? 5 by 5, so it's n by n. Before you confuse yourself any further, let's write that down. Okay? So I'm defining a function. There are some points just to have that correctly defined. Try that diag. And it says that it should have inputs D, L, and R. Those are some vectors coming in, colon. It's returning A, and I'm about to define A. So this shell you can write down just by reading the text and knowing what an input to function is, what an output to function is, and name of the function. And then first things first, let's just gauge, okay, what is the size of this matrix. So my D has a certain number of elements. I can use shape to figure out how many, or length, len. Okay, so let's use shape. And let's say that I'm pretending that I don't even know that it's a vector. So basically, my D shape returns the shape of D. And if I want to grab that information, I'm just going to store it. Okay. I can store it as some numbers, M1, M2. If you just want to test that quickly, give yourself an MP array that is given here, 2, 3, 5. Okay. The shape is 3. This would be general that if it returns one element, you can just put one element, should work in either way. So if I want to store this number 3, okay, I can store it. It's n, m1, whatever I want to call it. Yes? Yes, return actually returns the value. Print just prints it. So I can't print from a function. If I print, I'm just going to print to a screen. Return actually returns the value back to the program. Okay? So sometimes since it's kind of giving us result on the screen, it appears that there's no difference, but there is. Right? Print is just printing things on the screen. Okay? And return is actual function that returns something from this block of computation back out. And that's the only information that I'm actually providing. That's the only thing that is going out of the function. Okay? So since I started with n there and I changed my mind, the name, I can just do n. Okay? And let's print n. Now, this shape actually technically has multiple elements. So my A is this 3 by 3, and 3 is the first element, to grab it, I take n of 0.
You never like defined A, right?
Hmm?
You need that?
We are about to do that, which is why I need n of 0. So basically my A, if nothing else, I can just define zeros everywhere. Okay? This is one way using shape. I'm going to present you with another way. You pick what's you like. Yes?
What would happen if you made zeros and just n comma n? It would all zeros.
I think it might, which is I'm cautious here. Let's try.
Shifting, right?
Even though there's only one number.
Let's see if it works that way. I'm cautious, so I'm being very particular here. So NP zeros of n comma n. Yeah, it doesn't like that.
And that's
Because this technically has 2 entries, and one of them is empty. And that's just how shape function works. So this is one way. There's np.len. Let's try to do that. Oops. Oh. Then it's digital len. No, then I'm not correct. I thought that there was a function len. I'll explore. So this works. I did not think correctly. Well, this works. So now I created A, and if nothing, my A is empty. Okay? And there's already points to be learned just in doing this, which is just really starting. Now let's find the rule. My A of 0, 0 is which element of D? My A of 1, 1 is which element of D? I go to 5, right? 4. So if I'm just defining the diagonal, yes. Without NP. Okay, so that's probably done length without being numpy. Okay, we can do that. Thank you. So, if I was writing a for loop, what would I do? So here it's n0, 0, version 1. Or n is just len, not np. And A is pick the one you like. Now, the reason why I actually like this one, it's more general. So if I had shape that returns 2 values, the first value is n of 0, and the second value is n of 1. Do you mind if I just go on and finish this? So if I'm writing a for loop, okay, I can go over all of these values And over that range of values, I'm going to define A of I comma I as D of I. Now my L is to the left, and it actually has a leading zero, I believe, in the problem, right? Yes? So my A of 1, 0 is L of 1. My A of 2, 1 is L of 2. My A of 3, 2 is L of 3. And finally, A of 4, 3 is L of 4. Do we see a rule? So I'm going from element 1 to however many I have. And I'm saying A of I minus 1 is equal to L of I. I'm going to do a separate for loop just to make it simple. It could be done in the same loop, but that's... So this time I'm starting from 1. And because I'm starting from 1, I am allowed to subtract 1 here. And this is L. Suppose the point is write it down. Okay? On an example. In this case, example was given in the problem. Okay, you can create your own example. Yes?
Could you just leave the range as 0, comma, n, equals a, I plus 1, comma, I?
Then I would go outside of the range here, so I would still have to make sure that I'm not outside of the range. Then I would have to have a little if statement, okay? And I'm avoiding an if statement. But yes, it can be done within the same loop. So what I would really do here, I could say if I larger than 1. Then I can subtract 1, right? So that's up to you. I'm going to leave it simple. And now the same for R. Okay? So R has, the way it's defined, it has a 0 at the end. And I write the same rule. So now I have A of 0, 1 is R of 0. A of 1, 2 is R of 1. Write down. Won't work. A of 0, 1 is R of 0. A of 1, 2 is R of 1. A of 1, 3, 2, 3 is R of 2. And this is A of 3, 4 is R of 3. What is the rule? So I'm going from 0 to n minus 1. Yes? No, because then it's not defined for any size. Okay? So this is an example. Function has to work for any D, L, and R you give it to me. And it could be size 5, it could be size 3, it could be, right? Yes? So that's why we can't just go and type them all in for 5x5 things. Now, I return A, and if I'm calling this function, I have to define myself D, L, and R, and then I'm saying A equals to tridiac of D, L, R. So if I was now, I would have to have D, L, R defined, right? And the way I would call this and here it's already given, look, so, oh, diagonal left and right. Okay. Assuming that diagonal left and right are given the way they are on the exam. Yes? Questions? Is there anybody coming in here? Yeah, they are. So then I have office hours.